Good evening, my wonderful scholars here, my chemistry scholars. Tonight we're going to look at these combined gas law problems. And combined gas laws are really cool in that they take Boyle's law, pressure and volume, they take Charles's law, volume and temperature, the relationship there, and Guy-Lussac's law of pressure and temperature. They combine them all together into one formula. The cool thing about these is always look at the problem. Let's look at problem number one. Now here I have a gas that has a volume of 800 milliliters and it's at minus 23 degrees C and at 300 torr. That tells me I'm looking at all three variables. Now let's look and see what changes. What would the volume is asking what the volume is. That would be a question mark. That would be the unknown variable of the gas be at 227 degrees C and 600 torr of pressure. Looking at my pressure units, they're the same. My volume units, it doesn't matter. Everything looks cool. So let's go ahead and start setting this problem up. Step number one in every one of these gas law problems is to identify your beginning variables, your initial variables, and your final variable. So I'm going to write my P1, V1, T1 this time, as well as my P2, V2, T2 variables. Let's start filling them in. Okay, my first volume, my initial volume is 800 milliliters. My initial temperature is minus 23 degrees C. Now, minus 23 degrees C, I've got to convert to Kelvin. So I'm going to go ahead and put minus 23, and then I'm going to add 273. Now, when I add a positive number to a negative number, I'm really subtracting. But let's look at it. I got my handy dandy calculator here. Let's clear that out. So I've got 273 plus minus 23. And what do I get? 250. So my temperature is 250 degrees Kelvin. 250 degrees Kelvin. My first pressure is 300 torr, or 300 torricelli. I love that name, torricelli. It makes me sort of hungry, actually, like, spaghetti. But anyway, I digress. What would the volume be here? Let's see. Okay, our final pressure is 600 torr. Acelli. Again, so awesome. Wish I could eat carbs, but I can't. And the temperature, the volume, I don't know. So let's put a big pink question mark there. I don't know that one. And the temperature is 227 degrees C. Degrees C. Oh yeah, I've got to add 273 degrees to it. Add that up, carry that. I get 500 K. So I'm going to place that into my variables. Second step, let's write our problem down. Now our combined gas law is we're really just combining each of those variables, each of those three laws into one. So it's P1 V1 divided by T1 equals P2 V2 divided by T2. Okay. So now we're ready to start putting some things in. Let's put that first pressure in, 300 torr. I like using units because it lets me make sure that I'm going to be able to cancel those out as needed through 800 milliliters. All right, and in the denominator, let's put that 250K. Let me move this up just a little bit so we can still read it. Equals the first pressure, blue marker 600 torr, times V2. I don't know what that is, so I'm just going to put down V2. And then the final temperature is 500 K. Now, I get to do a little math. Again, we're going to cross multiply. So 500 times all those. And then 250 all those. So let's set that up so we make sure we do right. All right, my 300 torr times 800 milliliters times 500K equals 250K times, hold on, I'm going to run out of room, 600 torr times V2. So I've got to get my, I'm not going to do any math yet. I could hit my calculator and multiply all that, but I'm going to have big numbers, and I don't like big numbers. It gets very confusing. I have to write them down. So I'm going to divide, cancel out the 250K and the 600 torr. And if I do those on that side, I've got to do it by this side. So 250K times 600 torr. If I want to do a real good check, I'm going to cross through my units, and I should have my volume measurement. Okay, I'm going to cross out those units, and I do. That's going to leave me with milliliters. So now all I've got to do is hit my calculator. And guys, I'm going to show you a shortcut that would be very helpful for you on standardized tests. You don't have to do the numerator and then divide by the denominator. Let's do it like this, okay? All right, so I'm going to hit in 300 times 800. I don't know if you can see that or not. Times 500. All right, now I'm just going to hit divided by 250 and divide it again by 600. That's the same thing as multiplying those two together and then dividing by the sum. There's no need in that. Not the sum, the product, excuse me. I'm going to hit my enter, and I come up with 800 milliliters. So my V2 is 800 milliliters. Let's put this up here. Oh, man, will that happen all the time? No, it will not. And there's no way to check. You've got to trust your math. As it is, volume stayed the same. Even though you changed pressure, right? You increased your pressure. Even though you increased your temperature, okay? Volume stayed the same, which makes sense because, well, that's Gay-Lussac's law, okay? When pressure and temperature goes up, or when pressure goes up, temperature is going to go up, and at this particular time, volume stayed the same. All right, so there's your example, and we'll work some more of these so y'all can get through them. Okay, I'm going to sign off this one. We'll save the video, and then I'll do another one and go through a couple more of the odd problems so y'all can work on the other problems. Okay, so we will chat you up later.